You know, it's something you do about 20,000 times a day, and you probably don't even think about it. Breathing. But have you ever stopped to wonder about the absolutely incredible journey a single breath takes? Well, today we're going to follow that journey, and I promise you, it is way more amazing than you think.
Think about this. Over your entire life, you're going to take roughly 500 million breaths. That's just staggering. So for the next few minutes, let's hit pause and actually follow the path of just one of those breaths, from the air all around us, deep into our bodies, right down to the tiny cells that are literally powering you right now.
All right, so let's kick things off with the biggest question. Why? Why do we even breathe? I mean, the obvious answer is to stay alive, right? But the real reason is so much cooler, and it all boils down to one word: energy.
See, every single one of your trillions of cells is like a tiny little power plant. They're all running this process called cellular respiration. And that's really just a technical way of saying they take the food you eat, they use oxygen to burn that food, and boom, they create energy. But like any power plant, there's a waste product, and in this case, it's carbon dioxide. And that right there is the fundamental mission of your entire respiratory system. It's a simple but absolutely critical trade-off. Get the good stuff, the oxygen, in, and get the waste, the carbon dioxide, out. That's the whole game. Okay, so mission accepted. Let's start tracking that single breath as it begins its wild journey into the body. The first stop might seem pretty obvious, but trust me, there is a lot going on behind the scenes. The journey starts at what I like to call the VIP entrance, your nasal cavity. This isn't just a tunnel, it's a high-tech air treatment facility. First, it warms and humidifies the air so it doesn't give your delicate lungs a cold shock. Then, you've got these tiny little hairs called cilia, and they work with mucus to act like bouncers at a club, trapping dust, pollen, and any other unwanted guests before they can crash the party.
So once the air gets its VIP treatment, it heads down the trachea. You probably know it as the windpipe. This is the main highway leading straight to the lungs, and there's a really important traffic cop here called the epiglottis. It's a tiny flap that slams shut over your windpipe when you swallow, making absolutely sure your lunch goes down the right pipe and not into your lungs.
So let's trace that path again. Air comes in the nose, goes down the trachea, and then the highway splits into two main roads called the bronchi, one heading to each lung. From there, it's like a tree branching out. Those bronchi split into smaller and smaller airways called bronchioles, getting narrower and narrower as they reach their final destination.
And here we are. We've made it deep inside the lungs, to the very end of the line. This spot right here is where the magic happens. This is the whole entire point of the journey, the great gas exchange.
Our breath has finally arrived at the alveoli. Now, you have about 300 million of these microscopic, balloon-like air sacs in your lungs. Get this, if you could somehow spread them all out flat, they would cover an entire tennis court. This is the critical spot, the interface between the outside world and your bloodstream. This is where the big swap goes down. The air you just breathed in is packed with oxygen, but the air you're about to breathe out, almost all that oxygen is gone, and instead it's loaded up with carbon dioxide. It's an incredible transformation that happens in a split second. So how on earth does it work?
Well, it all happens because of a super simple process called diffusion. Just picture this. You have a room jam-packed with people. That's the oxygen in your lungs. Right next to it is a totally empty room. That's your blood, which is poor in oxygen. What happens the second you open the door? People naturally spread out into the empty space, right? Oxygen does the exact same thing. It moves from the crowded alveoli into your blood. And at the very same moment, carbon dioxide does the complete opposite, leaving the blood and heading into the lungs to be exhaled. Okay, so the oxygen is officially in the blood. Now what? How does it get where it needs to go? That is the job of hemoglobin. This amazing protein inside your red blood cells is basically a massive fleet of oxygen taxis. Each hemoglobin molecule pulls up, picks up oxygen passengers in the lungs, and then zips off to deliver them to every single cell in your body. So, we've covered the airway, we've covered the gas exchange, but we're missing something big. What is the engine that's actually powering this whole thing? What muscle is physically pulling air in and pushing it out all day, every day? Everybody, meet the unsung hero of the story, the diaphragm. It's this powerful, dome-shaped muscle that sits right underneath your lungs, and it is, without a doubt, the main engine of breathing. When you go to breathe in, your diaphragm contracts and pulls downward, flattening out.
You can actually feel this. Go ahead, kick a really deep breath in. Feel your belly push out? That's your diaphragm doing its thing. That downward movement makes more space in your chest, creating a vacuum that literally sucks air right into your lungs.
And breathing out, well, that's the easy part. The diaphragm just relaxes. It moves back up into its dome shape, which shrinks the space in your chest and gently pushes that carbon dioxide-filled air back out. It's so simple, so efficient, and most of the time completely effortless.
So we have this incredible, mostly automatic system working perfectly. But who's in charge? Who's pulling the strings? And what happens when this finely tuned machine is put under pressure from things like illness or the environment? Your breathing isn't just happening randomly. It is being meticulously managed by your brain. There's a part of your brainstem called the medulla oblongata, and you can think of it as the air traffic control tower. It is constantly monitoring the level of carbon dioxide in your blood. If those levels start to creep up, it sends an instant signal to your diaphragm and says, "Hey, pick up the pace. We need to breathe faster."
But of course, this perfectly balanced system isn't invincible. It faces some serious threats. For example, smoking can lead to diseases like COPD, which blocks airflow and makes it hard to breathe. Conditions like asthma can cause those airways to suddenly narrow, making every single breath a real struggle. And of course, infections can inflame the lungs, making that critical gas exchange much more difficult.
But for all the threats it faces, the system is also unbelievably responsive. Just think about what happens when you start to exercise. Your muscles are screaming for more oxygen, right? Well, that control center in your brain hears them loud and clear. It instantly cranks up your breathing rate and makes your breaths deeper to meet that demand and get rid of the extra CO2. It is a dynamic marvel in action. So, from a simple gust of wind entering your nose to a complex chemical exchange happening trillions of times a second in your cells, your respiratory system is working tirelessly for you. It's an automatic masterpiece. And that kind of leaves us with one final thought. Now that you know the incredible journey each breath takes, what can you do to help this vital system keep doing its job for the next 500 million breaths to come?
Want to test your knowledge? I've got something exciting for you. Download the worksheets for this topic. They're designed to help you see how much you've learned. It's a great way to check your understanding. So, what are you waiting for? Get them now and start testing yourself. The link is in the description. Go check it out.